All right. I had to make this quick video to talk about the elephant in the room. If you know anything about the React world, well, this discussion has to happen. Classes versus hooks. Now, as you learn in the course, there's many ways to build React components. And one of the newer ways to write these components is using hooks. Now, the way we've structured the course is the way that we actually recommend you learn how to write proper applications. The thing is, hooks are fairly new and they're exciting. So a lot of people talk about them, but they're also very specific to React. What you learn about hooks, you can't really apply to anywhere else in the programming world because they're so React specific. Versus classes, well, that's part of JavaScript. Learning classes is an important concept, not only in JavaScript, but a lot of other programming languages. Also, because hooks are fairly new, a lot of code bases in React still use classes because there's nothing wrong with classes. So the way we've structured the course is that we're going to teach you React starting with classes so you know how those work so that you can apply that knowledge to any of your future projects, or if you land on a project at a job that still uses classes, and then we're going to convert the app using hooks so you get to learn both ways. And we also started with classes because there's been a little bit of move lately in the industry where people are shying away from hooks because of the added complexity it adds to React. Now, this is a hot topic of discussion. It doesn't really matter whichever one you prefer. Our goal is to teach you both, and then you can decide for yourself what is best. The way we've structured the course is what we think is the best way to learn React. That is, starting with classes as they were intended, and then learning hooks afterwards to show what problems hooks solves that maybe we had with classes. So hang in there. We're going to cover both of these. I'll see you in the next one. Bye-bye.
We know that we can write functions that return HTML, but we can also write classes that return HTML. And the reason why we would want to use a class is because React has given us the ability to write classes that have a lot more functionality on them versus a function that returns some HTML. Now, let me show you this. So in order to write a class, we got to first import component from React, and instead of this function app, I'm going to convert this into a class. So class app extends this component that we get from React, and as a result, we now have access to this render method inside of our app class. And the render method returns any HTML we want. So let's return that HTML we had before inside of our function. And we'll see that it's actually the same. And to prove it, I'm going to change this tag, this text here, and we should see it update, right? Hello, Yihua. So this is great. So it's pretty much the exact same at this point as our functional app that we had before, right? Our function app that returned this block of HTML. But the reason why we would want to use this kind of thing is if we wanted, say, instead to display this static string of hello Yihua, what if I wanted something like, let's say, instead of an A tag, we had a button. And whenever you click this button, it would change the text to something else. Right? We would change this hello Yihua to something else. Well, the thing about that is that by using a class component, we actually get access to this thing called state. What state is it's some object, right? A JavaScript object with properties that we can access at any point inside of our class. And the way we would do this is we would actually call the constructor keyword here. And inside of our constructor, we want to call super, right? And what super does is it calls the constructor method on the component class. And what that does is it gives us access to this .state, right? This state property now exists on our class app, and we can set it to something. So this is the default value I want to set it to first. So let's say I want to set it to the string that we have right now, right? I want to set some property on our state object to hello Yihua. And then I want to render that instead of hello Yihua, this static string, right? How would I do that? Well, I would first use these curly braces, which JSX lets us do. And it tells the HTML that anything between these curly braces is going to be JavaScript. So I want you to render JavaScript, right? So we want to do this.state.string. And now between these p tags, we actually won't see anything change because it's the same string. But just to prove it, I'm going to say hello Yihua Zhang, right? There. We see that it's looking at the state, looking at this property string, and rendering that here instead. So that's awesome because now I can do this in multiple places, right? I can use this as many times as I want, and I'm going to see multiple versions of it, right? So what if I wanted to change this value? Well, the way I would do it is this class app that extends component. This component also gives us this method called setState. And what setState does is it lets us modify this state object, right? On every single HTML element, we now have access to this method, this property called onClick, which takes a function that gets called whenever this element gets clicked. So let's pass in this function, and in this function, we're going to say this.setState. And what setState takes is an object with all of the properties that you want to change on your state, as well as the new values that they have. So I want to change the property string to hello Andre. Now, when I click this button, we see that it changed, right? And that's really awesome because this gives us a lot of control over what we want our components to display. So this will be really, really useful later when we don't know where we're going to get some of the information that we actually want to display inside of our HTML. But I'm going to show you in the next lesson why this is really useful.
Hey there, it's Andre here. Wanted to add a quick note or a few things that you may have been confused about. You may be asking why we changed this from a function to a class. And older versions of Create React App actually started the app with a class instead of a function. Now, this topic of classes versus functions is something that we're going to cover more and more in depth as we get through the course. And especially towards the end when we talk about React hooks. Now, to go through this code, we need to understand a few things. The very first thing is that this syntax of JSX, which we're going to talk a little bit more about. But for now, it looks like everything is just an HTML tag. However, because this is JavaScript, there's a few changes. One is that this class name over here, that's not HTML, is it? And if I hover over this, you see that it's a JSX attribute. You see, because if I used the word class in here, class means something else in JavaScript. It means, well, we're creating a class, right? So JSX uses the syntax of class name to distinguish between what we actually mean, which is the actually giving it an HTML class, versus a class in JavaScript. The other thing are these brackets over here. You see how every time we write these curly brackets inside of our JSX, well, they mean inside of here, anytime you see these curly brackets, whatever's inside is a JavaScript expression. So what does that mean? Well, logo is a variable, which is the logo that we import. This.state.string, well, that's also a variable, which is referring to this state. It's a JavaScript expression. It's something that produces a value. For example, I could have done 4 plus 5 here if I wanted to, because it's a JavaScript expression. Another place that we see this is right here with the onClick. Again, Anything around these brackets is a JavaScript expression. So what's in here? There's a function, right? An anonymous function using this arrow syntax that simply calls this dot set state. Now, notice here how we don't actually modify this dot set state like this dot state dot string to equal something else like we would normally. And this goes back to the idea that I mentioned previously, which is this unidirectional data flow of React. You see, you're not allowed to modify state in React without calling this method, setState. Now, why is that? Because anytime we change the state, let's say a user clicks that button to change the state to a new string, when that click happens, what happens is React actually intercepts. Because remember, React is the one that's talking to the DOM. It's going to intercept that click, and it's going to report back and say, hey, I just got to click on the DOM. What do I do? Well, in this case, what we're going to say is on click, when the click happens, I want you to update the state. But we're not going to modify the state automatically. I'm going to say, hey, a click happened, state gets updated using setState, and then that change is going to re-render the component so that we can go through this flow again. Again, if we look over here, as soon as this setState gets called, which is when a click happens, well, what's going to happen? This render method gets called again. Why does it get called? Well, because state just got updated. State now is a different thing. And remember, the declarative approach with React is that as soon as state changes, we re-render the component with the new state, which is right here, and we display that. Now, this onClick, is that HTML? Well, if I hover over here, it says, nope, that's a JSX attribute. Again, remember, this isn't HTML. This is JavaScript. We're just mimicking HTML. So if I wanted to say use onClick in HTML, you see that onClick is written like this with no capital C, because in JavaScript we use camel case, it's a capital C. So just like class name was a little bit different than HTML, onClick is also different. So in React, we can use whatever HTML attributes that we want, like source, like class, like onClick, but sometimes there's these differences like class name or onClick. Now we're going to explore these different attributes throughout the course. But the key thing to remember is that JSX is trying to mimic what HTML does so that we can create that virtual DOM and break down each part of the app into these components that keep getting re-rendered as we update the state using setState. Let's keep going.
Now, let's start making our application resemble more closely to our actual final Monsters Rolodex application. So we know that we need to display a list of monsters. So instead of this string hello Yihua, I'm going to make a new property called monsters, and I'm going to make it an array of objects that have a name on it that's a string value. So our first monster will be Frankenstein. Our second monster will be Dracula. And our third monster will be a zombie. So here, I want to render, let's say, just a bunch of H1s with the actual names of these monsters, right? So how I would go about doing that is, I'm going to get rid of this because we don't need this anymore. And we write our curly braces because we got to render some JavaScript, right? So now between these curly braces, we can really render any JavaScript that we want. So I am going to call this .state.monsters.map because map returns us the return of whatever function we pass to it, iterated over every element in this array, right? So when I say iterate, what I mean is that this function that I write here, whatever this returns, it's going to return in the place of every element in this array. So I'm going to call map on this monsters array, right? And map takes a function where the first argument is going to be the actual element that this function is going to get called on, right? So it's going to call the function we pass in on it on Frankenstein, and then on Dracula, and then on the zombie, right? It's going to call it on each object. Now, what that function returns will be what gets returned out of this map. Usually it's a new array, right, when you call map, but React is smart enough to know that if we end up rendering out a bunch of HTML blocks, right, in an array, then it will just display those elements. So let's take a look. So our first element, right, our first argument is monster. So I'm going to return a new h1, h1, where I'm going to, again, call the curly braces because this is a new return block, right, of HTML, just like here, right? It's going to need new curly braces. And inside, I'm going to call monster.name. Now, what we should see is the name of each of our monsters, right? We see that. Now, if we open up our console, we'll see this warning that says each child in a list should have a unique key prop. So it's asking us to add a unique key to every child that gets returned out of this map, right? We got to provide something that is unique completely to this list of elements, right? So let's just make a value of ID and just call it something like this, right? Any random unique string will work. The reason why we want a unique key is because React needs to know what element it needs to update if one of these elements in our array has a value that changes, right? Now, let's say, for example, the user does something and it changes the name of our first monster from Frankenstein to Banshee, for example, right? Like, let's say it does it in the code somewhere, like the same way that we saw when we called setState earlier. Well, React is smart enough to know that it only needs to update that first H1, right? To change it to the new property. It doesn't need to re-render all of these. And the key helps React understand. It helps it know which element is the one that's been updated, right? Which HTML is attached to which element so that it knows that it doesn't have to re-render everything. You can see how if this list was way bigger, it would be really performant heavy to re-render everything. And that's what makes React so great. It's that it's smart. It knows that if only one element in a list of 1,000 elements changes, it only needs to re-render the part of the HTML that matters, not the whole thing. So now that we have our list, we actually want to make this look closer to the final. So right now, these are just placeholders for us to understand a little bit more of what it's like to write React, right? We're iterating over an array and creating new elements. But let's actually dive a little deeper into it.
Welcome back. In the next video, we're going to start talking about something called lifecycle methods and APIs. Now, in order to prepare for that lesson, I want to go over something that we already saw. That is this component, class app extends component. Now, what does that really mean? Component, if we look here, is part of the React library. And we're using destructuring here. But if I didn't include it like this, I could still use it using the React.component. Because component, well, is a property on React that we can use. And when we do something like class app extends React component, what we're doing is saying, hey, I want whatever functionality that this React component that was already built into the library by somebody, I want that functionality, and I'm going to add on to it. So for example, this render method comes built in with React component. And this React component gives us some batteries included options to use in our component so that we don't have to constantly repeat ourselves. We use something that React says, hey, this is a component, and we just tack on some specific functionality to it. As you'll see, we'll learn about lifecycle methods and how these components have some important methods already on them, such as if I type in COM here, you'll see that I have some methods that comes from the React.component lifecycle. But we'll get to that shortly. Another thing I want to talk about is this idea of an API. Remember how we talked about the birth of the single page application? How initially all we had to do with a normal web page was we visited a link and we got the HTML, JavaScript, and CSS file. When we clicked on another link, we went to a different page, so we got a whole new HTML, JavaScript, and CSS file. However, with single page applications, we now have this idea of communicating with the backend initially, where we get a tiny HTML page. Remember with our just ID of root, where we fill in our React component? And then we have this massive JavaScript file, or at least bigger than it usually was, with our React library, with our components, with any of our logic. So now, instead of having to communicate back and forth with the server, if I click on something and let's say visit a different part of the page, I don't have to go back. I can just have JavaScript or React say, hey, just re-render the DOM with something else. So now, with a single page application, instead of requesting a page, it's turned more into requesting for data. And this is when we have the ability to, let's say, communicate with outside servers, maybe servers that we don't control. For example, in our big project, we're going to talk to the Google Firebase database. We might talk to some different API endpoints so that now we can communicate with different APIs back and forth, and using JavaScript, just receive the data. For example, we saw that this JSON placeholder website, by entering into this website, all I get is, well, not an HTML page, right? All I get is this data that is formatted in what we call JSON. So this JSON data can be converted into, let's say, a JavaScript object that we can use. But all this does is provide us an API, a way for us to access information from, well, this server. So that now single page applications, instead of just rendering HTML, can use this data to perhaps display different monsters, different user information. And as we'll see, it will allow us to do interesting things like sign in, sign out, add items to the shopping cart. And we'll explore that idea throughout the course. And by the way, there's a way for you to actually check this. If we open up our developer tools and we go to network and I refresh the page here, you'll see that I have this users document. If I click on it and if I go to response, we see that this is the response that we get. So as you start to build larger and larger applications, what you'll find is that you'll start talking to APIs and trying to get different data for your application. And these endpoints or servers that we speak to can be third-party servers like Google servers, or they can be your own server where you perhaps have your own database. Now, that's something that we'll explore a little bit more later on. But the key thing is that the way we build applications now is very dynamic. Most of the time, we don't hard code all the information into these files. Instead, when a user opens something, we are always communicating with outside servers. So we're going to start structuring our app this way. Let's keep going.
So we just learned how to take an array on our state and turn it into elements that we can then see, right? Now, In a real world scenario, we're probably not going to hard code the information that we're going to have, right? Normally, we would probably get it from a backend of some kind of server, some kind of database. So I'm going to show you how that would actually work. Now, luckily, I have a pretty good resource where it will give us a sample of 10 users, right, without us having to actually build a backend server of some kind. And it's at this link. What it will give us back is this array of these objects, right, that have these properties like ID and name and email on it that we will use for our application. So what we need to figure out is how do we get this app component to make a call to the backend and then put that data into our state so that our render function knows to use it, right? Can have access to it. So how do we do that? You remember how we got the render method by extending into component? We also get a bunch of other methods that are called lifecycle methods. What are lifecycle methods? Well, if we look at this here, we see a list of all these methods, and it's an overwhelming list. But what lifecycle methods are is they're essentially methods that get called at different stages of when this component gets rendered. Now, I know that's kind of jargon right now, but I'm going to explain it to you throughout this course. But the main one I want us to focus on is component did mount. Now, what component did mount does is it's kind of like the name, right? When this component mounts, mounting is essentially when React puts our component on the page, right? It renders it onto the DOM for the first time. When it does that, it calls whatever block of code we write inside of here. That's all it does. So what we want to do is we want to use JavaScript's native fetch, right? To fetch from that URL, make an API request to that URL. And what this fetch returns us is a promise, right? But that promise gives us a response of the actual body of our response. But we don't know what that looks like at first, right? So let's just log it out and see. So we see this response object, right? It's got the body and it's got these headers. It's got all these properties that we don't really care about. We don't really need them, right? The main thing we want is we want the body, but we want it in a format that our JavaScript understands, in the format of JSON, right? So let's, from here, return response.json, which is a method, right, on this response object that will give us back that response in the JSON format, which we want. And then that will get returned to us as a new promise, which we will now have as the body, which will be this array. So when we get that array, let's just log it again so that we know what we're getting. We see our array, right, in the format, in the objects that we know and we can use. So what we want to do is now we want to call set state as we did before, but now we want to set our monsters to this array of these users, right? And we want our initial state to be an empty array because we don't need to hard code it anymore, right? We're gonna wait for our component to mount, and then we're gonna fetch all of our users, and then we're going to update our states monster property with this new array of users. And now when we check our application, we see that we have all of our monsters or users, right? And we're displaying all their names. Now we see this error here, right? It's just a warning, and it's telling us that we're not using the logo anymore, so let's just get rid of it. That's the great thing about Create React App as well, is it comes with linting. We can be aware of writing and making our code clean. So now, just to go over this again, we're using this component did mount lifecycle method that we have access to because of our class component. And we are fetching from this URL. We are taking the response and converting it into the JSON format that our JavaScript can understand and use. And then we're going to take the users that we got back from it and set our monsters to that array of users. And that's how we end up with this list of users. In the next section, we're going to now convert this to look a little bit closer to this.
Welcome back. Now, before we get into the next video where we're going to build some of these components and actually start making our app, I want to go over something. You notice here that we're rendering this app, which isn't HTML, but our own custom component. That is, we're importing this app file, which is app.js. And don't worry about this code. This is something that we're going to write later on. But we see over here that we're returning, under the render, some HTML. Now, the way React works is that we can combine these HTML-like elements, such as div or h1, but also create our own custom ones, like search box or card list. And just like we saw on our developer tools with React, these components, we have capital letters, and I've used some highlighting here so that it doesn't highlight them. You can see the difference between a component that we built, which starts with a capital letter, and a component that comes pre-built in React, which are like HTML, div, or h1. These are lowercase. And as you remember with the React component architecture, all we're doing is just creating and combining these Lego blocks together. And the syntax is either using the class syntax with a capital letter. So now we can use the app component. Or if we go to something like search box or card list, let's do search box. Again, we won't have this here, but we will build them over the next couple of videos. You'll see that here I have a different way of building a component. And this uses just an arrow function. So remember when we first did the create React app, how we had function, search box, or in our case, we had the app. That in here, we returned some JSX, like h1. Well, this is the same thing, except that we're using the arrow function way. So there's two ways like this of creating components, the class component and functional component. Now, that's something that we're going to go get into a lot because it's an important concept in React and has some implications, but we're getting ahead of ourselves. The key here is to realize that we have, for now, two ways of building components, either just as functions like this, again using capital naming system, or using classes like this. And both of these, no matter what, always return some sort of JSX for us, some sort of React elements. Now, another thing I want to mention is the folder structure that we're going to build throughout our course. And a good folder structure is really, really important on any project. As projects get bigger and bigger, as we get more and more JavaScript files, things are going to get complicated, so we need to be organized. So we're going to be structuring our app like a lot of professional React developers are, so that we stay organized. And what you'll notice here is that Ihua, when creating components, likes being very explicit. That is, if a component in this component folder has JSX in it, he actually ends the file with .jsx. And you see we have that little React icon. If I go down to the bottom over here, you see that it's JavaScript React. So JSX simply means it's JavaScript, but with this JSX syntax. Now, if I change this to a simple JavaScript file, it's still going to work. It's why app.js still works the way it does. And this is actually just personal preference. This is how Ihua enjoys organizing his code, because this right away I can look at it and say, oh, this is a React JavaScript or JSX file. But at the end of the day, Remember, Create React App takes everything through Webpack and Babel. We'll actually convert this JSX file into a JavaScript file. So whether you do JSX or JS, it doesn't really matter. Maybe your editor will help you with an icon, but that's about it. It's just personal preference. It's all about structuring your application in a way that's easy to understand. That makes sense. Even the naming convention here is important, where, again, just by looking at the file, even though it's in the components folder, right away I know, oh yeah, this is a component and this is the style for the component. Now, these styles, these CSS files that we're going to be writing, and trust me, we're going to be writing a lot of them. At the end of the day, what happens underneath the hood is that Create React App combines everything all together. And if you remember, if we go back to our test folder, when we run npm run build and we go to the CSS file, you see over here that we have a chunk of CSS with a .map. This is a source map, which just helps us debug our code in production. But we have just one massive CSS file. And that's what Create React App does. Even though we'll have different CSS files in our workspace, in our source folder, at the end of the day, when we release to production, all of these are going to get combined together. And although we're still early in the course, although we haven't really built out these components, I want you to start noticing these things. As we build things, we're going to be thinking about how to stay organized. Instead of just having all the files in one directory, instead of not having any organization, right from the beginning of the project, we're starting to think about how we want to architect it. And this is an important principle that we're going to take with us throughout the rest of the course. Let's keep going.
Okay, so now we're going to start converting our current application to look more like the final application. Before we do that, we got to take a look at this idea of components. So right now, we do know that our only component is the app component, right? We've only written this one single class-based component, which is our app. However, in React, what we want to do is we want to be able to break our code into smaller, reusable pieces that are only focused on one responsibility, right? So when we look at this, we see that this card seems to be its own component. This search bar is its own component. And in a way, because this card is itself, it doesn't really care about the other cards around it. So there's got to be something that seems to be containing every single card on our page. And that is going to be another component. Now, when we build that outside wrapping component, we're going to actually take a deeper look into what components are in React. So let's first make a components folder. And inside, we will make a card list folder. And in that card list folder, we're going to make a card list.component.jsx. Now, you don't need this .component part, but I like to add it just so that I can tell right away what kind of file that is. So this is our component file, and we need to import React from React. And we're going to export out this card list, right? And it's going to be a functional component. And what we want to display for now is just a containing div. Now, one of the big things about components is that they take in something called props. And props is going to be the parameter that we get from our functional component, right? So right now, let's just log this out and see what this looks like, because it's important for us to know what props actually are. And inside of this div, I'm just going to put hello for now. And let's console.logout props, right? So now we know that we're logging it out when we put it on our actual application. And we're going to import it into our app file. Import card list from components, card list component. Now let's just put this above here for now. And let's not put anything into it. Now, you remember earlier when I said that there are this props parameter, right? This is actually going to be any parameter that we pass into card list. So if here we say there's a prop called name and we pass in Yihua, right? Then what will actually log out when we look at our app is this card list that says name, right? And then it says Yihua. So right there is our card list component. And right here, you see that we're actually logging it out. We're logging out Yihua, right? So that prop is going to be an object of any properties that you write onto this component where it gets used. Now, generally speaking, of course, we want the props that we're actually going to pass in to match the parameters that we're actually going to use inside of our component. But one of the main properties that exists on this props object is one called children. It will always be there, but if there's no children, it'll be null. So what are children? Children are actually what you pass in between the brackets of our component that gets called. So if in here I say Yihua, then the children prop will be this Yihua, right? Actually, I'm even going to make it an H1 just so that I can show that it's anything in between these tags. So now, if we instead render props.children, got to remember to use the squiggly brackets because that tells that we're going to use JavaScript. And now we see Yihua. And this is an H1 as well. So that's one of the big things about props and components. We actually have access to props as well on our app component on the this keyword. It gets attached to our actual class as a property called props. So if we wanted to access it, we would use this.props. But because we're not using it yet, there's no reason to do so. But in a later lesson, we'll actually see what that will look like. But for now, let's just focus on our card list. So we're adding in these props, right? We're passing the children in because we do want that. And then we're going to actually do some of the styling to make it look more like this. So we notice that this is in kind of like a 4-column grid. Well, I actually have some of the CSS written already for us that you guys can get from the file, but I'm just going to include it. And I don't want to focus too much on the CSS because it might be a little bit too much to think about when we're trying to learn React right now. But there is one thing I want to highlight. So first, let's make a card list.styles.css and let's add that in. So all I'm saying really quickly is that I'm using the new CSS grid, right? I'm setting the display to grid. I am saying that I want the grid to make everything fit within 4 of these columns, each one being the size of 1 fraction, which is essentially an equal part of the overall size of what the width of this card list will be. So there's just 4 equal columns, and then between each column, there will be 20 pixels. So let's use it and see what it looks like. So let's import that in. And then let's put it on. So let's get rid of this for now. And let's put it on. So our class name will be cardlist. If we save it, we will see now that Yihua is in here, right? But we want everything in there as well, right? So now, instead of passing Yihua through, I want to pass all of our monsters through, right? So again, this map is going to generate our list of those H1s the same way, but then it's going to put it as the children in between this div that we have as our card list component. And now if we look, we see that it's in an equal grid of 4 equal columns. So this is a really fundamental thing about React, is that we're just building components that only care about one thing. And our card list component only cares about displaying cards inside of it in some kind of configuration, right? Now, the next thing we're going to look at in the next lesson is taking that idea a step further, and we're going to apply it to this card component next. See you in the next one. Now that we know what to do with our card list component, we can actually take it a step further. So earlier, we were just passing children in and rendering it between our outside div. But we don't actually want to do that because right now, our app component is actually the one that is currently responsible for mapping over that list of monsters and then creating those elements. But we actually want to give that responsibility to the card list component because the card list component should be the one responsible for listing the cards. So let's actually move this into it. So first, what we're going to do is we actually don't need this anymore. This is completely unnecessary. We're going to pass in the monsters as a prop from our app component. And then we're going to move this into the card list. So we know that we don't need the children anymore. Instead, we're going to generate it ourselves. And it's not off state, it's off of the props. So if we do this, everything should stay the same, which it does, which is awesome because now our app doesn't have to worry about creating those monster cards, right? The card list component is the one that's responsible for it, which is great because that should be the responsibility of the card list component. But what the card list component is not going to be responsible for is deciding how this component will look. So yes, we could create our element and add those images all here, right? But then we don't want to do that because we actually want our card list component to not have to think about that. It should only think about what it should add, right? It should only think about rendering them. It shouldn't actually think about how to create them. So we're going to make a new component to do that. And that component is going to be a card component. So let's make a card folder in our components folder. And inside, let's make a new card.component.jsx. And we need to import React like we always do. And we're going to export this constant card, which is going to be a new functional component that will return a div. And inside, we're just going to make it the same thing that we had earlier, right? Now, this key actually is still going to go on our component. We're going to make sure to do that because we want React to still be aware that if any of these monsters update, I only want you to update that one element that gets affected, right? Now that we know that, what we want to do is we no longer have access to the monster in the scope. So what we got to do is we're going to pass that monster the same way we passed monsters into the props from our app.js, right? We passed monsters in. We're going to do the same thing, and we're going to pass an individual monster into our card component. So we're going to do props.monster here and make sure to add. Let's first import the card from card component. Oh, we actually don't need any of that. And then we got to pass a monster into our card component, right? So we're passing monster into the card component, and then the card component gets it from the props and displays the name. And if we check, it stays the same, which is awesome. That's exactly what we're looking for. Now, to add the styling, to make it look closer to our actual application. Just like before, I have the styles already written for you guys. We're just going to do the same thing that we did last time. We're going to make a new card.styles.css. And then we're going to use this card container class and the styling for it inside of our card. I forgot to import it, of course. Don't forget that We got to import those styles in to our file. Now we see this card has all of these stylings on it, right? Just like before. It just doesn't have the image anymore. But just like our final application, it's starting to look much closer. Now, where do we get the image? The image I actually get from this website called RoboHash. And from RoboHash, it's very easy to get unique images of these funky looking monsters just based on a changing number that you pass to the URL, which is really great for our purposes. So we are going to add a new image, right, with an alt text of monster. And we're going to do our source, which is RoboHash. Except instead of this number, we are going to add our props.monster.id because the ID is a unique number. And then this is what's called a URL parameter. So with this parameter, I'm essentially saying to use this set of images. And it's all on the website. You can see what other parameters you can add. But another great one we can add is size. So if we add an ampersand, we can say size equals, and I want to do 180 by 180. Now if we save and we look at our image, we see that it's there. We see we have these robo images and we have our names, and now we're looking really close to our final application. So let's just add the email as well. And instead of an H1, let's use an H2 and then a P, and let's just do props.monster.email. And now when we look, we see it looks exactly like what we have in our application. Awesome. So now in the next section, what I'm going to add is the actual search bar. And we're going to see how we can filter out and add more functionality to our components.
Hey, it's Andre here. Just a quick question. Why do you think we keep breaking things down into components? I mean, in the previous videos, we created this card list component that renders this div with something inside it, some children inside it. And then we broke that down even further to have cards that are being rendered. And you might be asking yourself, why exactly is that necessary? Why can't we just put everything in app.js and have just one big, JSX? Isn't that simpler than dividing everything into all these small components and so many files? Isn't that confusing? Before I answer that question, I do have a question for you and a little exercise. When do we break things down into components? Pause the video here and think about what the benefits are of breaking things down into smaller and smaller components instead of one big giant one. Ready for the answer? Remember this? When I told you that to be a great React developer, you have to do these three things really well. This touches on the first point, which is deciding on components. And if you remember our example, where we had this little website that we broke down into different components. Remember here and here and here. You can see over here that each part is a component. Now, the reason we would, let's say, if we had an app like this, we wouldn't want to code it all into one file, is that the benefit of React is in the idea of this component architecture that can be placed and used in multiple locations. So that means that when we do something like this, sure, we could have kept all the cards in here without creating a new card component. But now this is more flexible because this card list can now be passed different properties. For example, instead of the monsters, maybe we have fairy tale characters. And this card list component can be used on a different project or a different part of the app, because it no longer cares what it prints out. I mean, sure, it can print out this card component, but maybe we have a fairy tale card component now that we can just inject into here instead of this card one. And by breaking things down, we're making things more flexible because each component does one thing and one thing really, really well so that it can be used in other places. The bigger a file gets, the more JSX we have, the more logic we have, the harder it gets to be used in another place. And this idea of breaking things down into small individual chunks is really, really important. And most good React projects break things down into a pretty small component file that the name pretty much tells it exactly what it does. Just one small thing. And the other benefit that we will also encounter later on is that we also have this flexibility of performance improvements, potentially, as well as having components that are really easy to test because they're so simple. Now, those are topics that we'll uncover later on. But the key here is that the reason we break things down into smaller and smaller components is that we combine each component with its concern. And that concern is that this component is only concerned about card list. This component is only concerned about cards. Now, this is an idea that we're going to explore throughout our course. So if you don't get it 100%, don't worry. We still have lots to cover. So let's keep going. Let's talk a little bit about state versus props. Now, one thing you may have noticed is that we have this parent component called app that pretty much surrounds everything in our app so far. And only here we have state. Now, this state we pass down to the card list component as, well, an attribute, right? Just like we have HTML attributes, we send down monsters and give it our state. So what you notice here is that as soon as we pass our state down to a component, this component receives it as a prop. And this is what we'll usually see happening through our apps. We have state, which often is something that changes because of user interaction. Well, what changes because of user interaction? The monster changes because when we click refresh on a page, we update the state monsters from an empty array to a filled-in users. Now, this state trickles down our component tree as props to whoever needs it. So if you remember this diagram, this idea of one-way data flow or unidirectional data flow, in our case, we have this app component that's at the very top. It's the parent component. And then this component has state that whenever something changes in the state, it will trickle down, if we pass that information down, to whatever component that cares about it. Remember, we pass it down as an attribute. So that state gets turned into props, into all these little components that we pass it down. In our case, the card list component gets passed down the monsters. And they use it as props. So remember that state usually lives in just one location, or a specific state only in one location, and it trickles down as props. If we go back to our monsters example, if we open up developer tools here, and remember, we use the React developer tools. If you don't have it by now, I highly recommend that you download the extension from the Chrome Web Store. You see that we have the app. On the right-hand side, it shows me that the state is monsters, which is array of 10, and search field. Now, this search field, we haven't worked on it yet, so don't worry about it yet. The key here is that we have these monsters. And this state, if we go down, gets passed down to card list. And right here, you see that the props is monsters. So even though it's the same thing, state turns into props when it gets passed down. Now, if we go down even further to the card items, we see over here that these card items get passed the monster prop because we only passed on one monster at a time. Now, you might also notice here the key that we gave each card. Remember, key is used by React to distinguish when multiple components are rendered one after another. See here how we have all these card components, 10 of them to be exact. If one of them changes, React uses this key attribute to say, hey, key 3 changed, do a quick render. So this is that internal React working for us to make sure that when they update the DOM, it's going to be efficient and only update one of the cards if it updates instead of all the ones. But the React Developer tool is really, really useful to see how information is being passed down. Now, again, remember the keys to being a great React developer? The second point was to decide the state and where it lives. Now, up until now, we've only had state in our app component. But as we move further along in the course, you'll notice that we can put state wherever we want. So before we even get to that, let's think about this. I have here just a simple little tree-like structure. And you can ignore the numbers for now, but you can think of this as our app, where we have the app.js that has different components down here. Now, right now, in this orange part, this is where the state lives. So let me ask you this. If the state changes right here, let's say our monsters grows from having 10 users to 20 users, what happens? Well, a state change is going to happen with setState, and then we're going to announce to whoever cares that, hey, the monsters array has changed. And whichever component has those monsters passed down to is going to say, oh, I received new props. That means I have to re-render. So again, it's going to say, hey, I have new prop information. Who needs it? And whoever needs it gets passed down that prop information, so on and so forth. So if you think of this as a function call to render, remember, each component at the end of the day is a function that renders. So if state changes, it's going to notify this component and say, hey, run the render function again. 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 So when we talk about deciding where state lives and how we pass down props, we can see here that there are some performance implications because every time state changes, we're going to have to rerun functions because the properties or the inputs of the function change. Now, this idea of performance is something we'll talk about later on in the course when we learn a little bit more. But I want you to start thinking in terms of this tree that we're creating and how every time we introduce state or data into our app, that data gets passed down as props. Finally, remember that this RoboHash that we're using right now is an API. Same with the user's data. So what we've done up to this point is essentially have an API call to get the users when we initially load the page with our JavaScript, CSS, and HTML file. Create React app just simulates when we run it a fake server that sends these files. We get the users and it then gets each image of our monsters from another API, the RoboHash. So this is what we've built so far. But we have a lot more to go through. So let's get started in the next video.
Now that we have our card and card list components, the next thing that we want to add in is our search feature. So if we go into our final application, when we look at the search feature, what we see is a text box that takes a user's typed inputs and filters out the cards based on what they type in. So if I type in LE, it will filter out any monster whose name does not have LE in it. Now, how do we build this? Well, let's first go back to our application code. And what we first need is the HTML element that will represent the text input. And what we're going to use is an input HTML element. Now, these input HTML elements are pretty much just basic text inputs. If we put type on it, which is a HTML property that all inputs have, we can give it a different string, and that string will help us get some features in the input that we might want for different types of inputs. For example, if we use password, whatever we type will become hidden. And the one we actually want will be search. And what search gives us is the ability to put on this placeholder, which will essentially put a string there when we haven't typed anything into the search field. So now we'll say search monsters, and that is the placeholder, right? But once we type, we see that it gets hidden. And then we can clear it away with that little X button. So type search allows us to use that placeholder, but now what we need to do is we actually need to be able to hijack or take control whenever the user types something into the input, because we want to store that string on our state. And by storing it on our state, we're able to use it in order to actually filter out our monsters. So let's first figure out how to store that on our state. Well, the first thing we would do is actually add a field to our state that would represent what that stored value will be. So we'll call it search field, and we'll make it start as an empty string. Next, what we'll do is we actually have access to this method on our input called onChange. And what onChange does is it fires with this synthetic event, which is essentially just an event in our browser, right? Whenever the input is changed. So whenever the user types or removes anything. But let's just take a look at what that looks like. And what we pass to onChange is actually this function where E represents the synthetic event we're talking about, right? And for now, let's just console log E, and we'll see what happens. Let's go to our browser and open up our terminal using right click and clicking inspect, and then hitting the console. Now, whenever we type anything into our input, we will see our onChange fire, which was that function that we wrote that logs that synthetic event. We also see that it changes whenever we remove any of the characters. And this is because it's literally as the method says. Whenever the value in that input changes, fire my onChange event. Fire the onChange with whatever function we pass to it. And what we'll see on our synthetic event is that it's this huge object with all these things on it. And this is because it's a native event that the browser uses to do all kinds of different things, right? It gives us a lot of control, but we actually don't need to worry about more than like 99% of the stuff on here. The main thing that we do want to look at is this target value. There's a get and there's a set, but that mainly means that we can either get the value of what target is or set the value. But we don't want to set the value. We just want to get the actual target value. And what it will give us back is the HTML element. And we can see if we log it. So when I say that it gives us the HTML element, it's because it's the HTML element that fired the event. So if we now log it, we see that that's our input. And we can actually hover over it and it'll tell us where on the page that element is. And there's our search element, right? So what we want off of this is actually the value. And value is a property on the input that will give us literally the string value that it holds, right? And see, as we type it, we're getting that string value. And that's how we're going to be able to store that on our state. Now, how do we store this? We can do this by calling setState here the same way that we did when we got our users when inside of our component didMount method. So what we can do is call this .setState, and we can pass it that we want our search field value to be the e.target.value. Now, if we wanted to see this actually persist, right? If we wanted to make sure that our state was being updated, Normally, what we would think to do is just console log after we call this.setState. So we would think that if we called console log this.state, that we would see our state update. Now, let's actually test this out. We see that as we type, it looks like our event is firing, but our search field key is always one letter behind, which means that the first time we typed D, search field was actually not updated, right? Why is this? Well, this is actually because setState is an asynchronous function call. So asynchronous versus synchronous is a big thing in JavaScript development, especially in React. Synchronous action is something that we can expect to happen almost immediately. It's something that pretty much happens and JavaScript knows the amount of time it'll take. So JavaScript will wait for that thing to finish before it continues, right? Running the rest of the code afterwards. An asynchronous action or event is something that actually takes an indefinite amount of time that JavaScript does not know. So what it does is it actually runs the rest of the code after, and then when the asynchronous event finishes, it then runs that finished event. Now, I know this sounds confusing right now, but I promise that we'll cover it later when it makes more sense to do so. Right now, the main thing I want you to focus on is just that this setState is actually not happening immediately when we would expect it to, which means that yes, our state will be updated with this value that we've set here, but it's not going to happen in the immediate sense that we would expect it to. Instead, what we would do in order to log our state, there's actually a solution that React has given us. And it's going to be the second argument that we pass to setState. Now, it's going to be a callback, which runs after setState is finished. So after setState has updated our state, it will run the function that we pass. And here we can log this.state. And here we'll see that when we type now, we do see our newest, latest value. So that's a thing to remember with setState. If we wanted to see or do something with our state right after we set it, then we have to do it inside of this second argument function that will get called right after setState. Okay, now that we have our search field being stored, let's actually filter out our monsters. But let's return our code back and get rid of this part that we don't need. So let's remove that. And then we don't need these brackets either, because all we want to do is just call our setState value.
Hey, it's Andre here. I want to make a quick note about this onChange event. Let's demystify some of the code here. Now, the first thing I want to point out is this onChange, remember, is in JSX. It's not actual HTML. Remember this diagram? When the DOM changes or reacts to a user input, in our case, searching for a monster, it's going to say, hey, there's an event. Somebody has just typed in something into the input. However, what React does, remember, we don't manually touch the DOM. If that were the case, we would be using the onChange event natively in our HTML, using something like this. But because we're using JSX, and by the way, if you're not familiar with HTML events, I will link to a great resource that talks about this so you can learn more about them. But again, it's just something that the DOM gives us in order for us to interact with user events. React actually has something called synthetic events. And I do recommend that anytime you have questions throughout the course to Google things and go visit the React documentation because, well, they're the ultimate source of truth when it comes to React. Now, what are these synthetic events? If we go back to our diagram, when a DOM event happens because let's say a user clicks or types something in an input, the DOM onChange event is going to say, hey, something changed. Now, React intercepts that and says, oh, something has changed. Let me go tell my React app that something's happened. And this is what a synthetic event is. A synthetic event is kind of like a fake event that we pretend is a DOM event, but it's something that, well, our React robot is telling us, saying, hey, there was an event on the DOM. What should we do? And this is our synthetic event. You see here that it's camel-cased. So it's not actual HTML, but a synthetic event onChange that we use to detect whenever that DOM event happens. We receive that event because something has happened, and then we update the state. Remember, state is simply something that usually changes in our app due to a user action. In our case, the search field is going to change because somebody has typed into the text box. Now, if we look at this code over here, some of you might be asking why we don't just run this function. If you look over here, all we're doing is actually defining the function and not running it. We could extract this entire piece of code and put it up here, which by the way, we will in a later video. Because we're not running it here. We're just saying this is an anonymous function that gets triggered on change. And this is an important distinction here because you would never run setState in render because, well, that's going to create some errors. You can actually try it out for yourself, trying to call setState in render. Because every time you call setState, it re-renders. And every time you re-render, it's going to call setState. It's just going to create a loop. So what we're doing here is we're actually defining a function, not running it, just letting them know, hey, on change, I want this to happen. And React internally with this synthetic event is going to say, hey, anytime on change happens, it's going to be an event, just run this function. Now, the last part is this over here. Remember how Yihua said that this doesn't get logged right away? And that's because, once again, React is smart. We're not actually interacting with the DOM. What it's going to say is when we do setState, it's going to say, hey, ReactBot, we have some updates that we want to make to the DOM. Can you do it for us? And our little robot is going to say, yeah, I can do it. But you know what? I know when the best time to do that is. I know when to do it. Just let me handle it. I'll take care of it. So it actually doesn't happen right away. What it does is essentially it schedules and batches work. So if there may be multiple updates that need to be done, then it can actually optimize that for us. And that's why React is good, right? Because it figures out for us the best time and the best way to update the DOM. We just tell it that we want an update. It's declarative. But we leave that internal working to this little smart React bot that's constantly improving with new updates so that we don't have to worry ourselves with the DOM. And that's it. Let's go to the next video.
Okay, now that we have our search field value stored on our state, let's actually use it to filter out the monsters where their names don't match the field. Now, how we'll do this is in the render. We don't want to actually modify our state's monster array because we want to keep the raw data in case somewhere in this component we need to use the base unmodified array. What we'll do instead is make a new array using the .filter method that we've learned. So what we'll do is we will actually first use a concept called destructuring. And what destructuring allows us to do is pull properties off of an object and set them to constants that we put inside of here. So the syntax is we say const and then we put our bracket notation. And here we'll use the actual object we want to destructure from. So the state object is what we want to pull the properties off of. And what we want to do is use the same property name that we want to set as the constant. So when we say monsters and search field like this, we'll be pulling off the search field value and the monsters value off of our state object and setting them to constants called monsters and search field. This is the equivalent of saying const monsters equals this dot state dot monsters and this, and const search field is equal to this dot state dot search field. It's just an easier way and a quicker way for us to write this out. And now that we have our monsters and search field, what we'll do is set a new const called filtered monsters that we will set as our monsters.filter, right? And we remember from our filter method, we get back a new array based off of the function that we pass into it, where we'll get the monster that it's currently iterating over. And what we want to do is take the name, call to lowercase on it, which is a method on all strings. And here we see converts all the alphabetic characters in a string to lowercase. And we want to do this because we don't want our search to be case sensitive. If we did, we would just not use the to lowercase. And then we'll call dot includes. And what this includes method does is similar to our array method. It just checks whether or not the string value we pass inside of our includes is actually in the string that it's being called on. So here we'll use our search field. And we also want to lowercase it because, again, we want to make sure that if the user types in capitals, we don't want that to be case sensitive either. So includes, just like the array method includes, will return true or false based off of whether or not this string includes the string we're passing to it. And now, instead of passing in our state of monsters, we'll just pass in our new filtered monsters. And now we see that as we type, we're filtering out the monsters that don't have what we've typed in inside of their name. Now, we'll notice that our component is actually re-rendering every time. This is because whenever setState is called and the properties change, React re-renders our component. It recalls the render method, which means that our filtered monsters method here is actually getting called again. And this is great because what we've done is we've triggered the setState whenever they've typed something in, which in turn sets the state value of search field, which then in turn causes our component to re-render and recall the render method, which then refilters out the monsters by calling our monsters.filter again, setting a new array, which it'll then pass to our card list, which then re-renders card list. And this way, we're able to just dynamically live update our card list based on what we're typing in. And this is what's great about React, is that React is able to take control of what to render, what to re-render in its views, without us having to do all the extensive calls of showing elements and hiding elements. React is able to do so for us as long as we understand the rules. Now, we will definitely explore this in greater depth a little bit later, because right now we have to just expand upon some other concepts. But I promise you that we will take a deeper dive into how this works in just a little bit. Now that we have our search component, we might actually want to be able to use this component multiple times. Because if we look at the code for our input, all it is just an input that doesn't need any local state. Even though it seems like we're calling setState in our input, it's really just a function that we're passing from the context of our app component into the onChange handler of our input. But this means that we can probably move this into its own component because maybe we want to have a reusable search component. Well, how would we do this? Well, let's just make a new component called searchbox. And we'll create the usual file, searchbox.component.jsx. Now, some of you might have noticed, why is it that some of our files have .jsx and some have .js? Well, you remember how I mentioned earlier that Create React App hides away some of the configuration for Webpack and Babel? Well, what Babel does is it helps transpile down any of the modern JavaScript, including JSX style files that we write, into older versions of JavaScript in the public folder when we finally run our build script inside of our scripts file. Now, in this transform, if we look at our .js file for app.js, we actually see that it says JavaScript Babel down here. So even though we're writing JSX code here, right, because we're rendering HTML in our JavaScript, Babel knows that it should probably run this regardless through a JSX transform, even though it's not a .jsx file type. We'll explore this much later in the course when we actually write our own Webpack and Babel configurations, but right now just know that whether or not you write .js or .jsx in the context of Create React App, you can write JSX in both file types. But we want to write .jsx in ours because we want to be explicit. We want to know that if we're going to write JSX, well, this file type is JSX. We're also going to create our searchbox.styles.css. And I've included the styles for you, and you can find it in your resources. So you just want to copy that file and paste it in. And then you want to import it into our searchbox component. So let's first import React from React. And then let's import in our style sheet. Now we're going to use another functional component. Now let's go a little deeper about functional components. So functional components, unlike class components, such as our app.js component, they don't have access to state because they don't have access to constructor, which is a class method on our component that we import from React, that we extend our class from. They also don't have access to lifecycle methods. They don't have internal state and lifecycle methods because we don't always need to use lifecycle methods or internal state. Sometimes all we want to do is render some HTML. And that's what a functional component really is. Unlike a class component, a functional component is just a component that gets some props and returns some HTML. And we'll figure out as we build our apps and see more challenges when to use each. But for now, the main thing to remember is that if you don't think you need internal state, nor access to lifecycle methods, then just use a functional component because it's easier to read. It's actually easier to test, as we'll see later in the course. And it's in some ways smaller and easier to reason about. So we'll just copy over the input that we want inside of our searchbox component. And we'll apply a class name of search to it because that's where our searchbox styles are applying those styles to. We'll keep this type because we know that it's going to be search. And then as far as placeholder goes, we might want this to be dynamic because maybe another place that wants to use searchbox doesn't want the placeholder to say search monsters. Let's say they want to search people or anything else. We want placeholder to be a prop that gets passed in. And as we learned with our destructure, we can destructure that prop off of the props object because all the props come in as one big object. So let's destructure it off and then pass it into our placeholder. And then onChange can be another prop that gets passed in, which is a function under the name of handle change. And we'll destructure that one off as well. And then we will replace the value inside of our change right here. Now let's export our search box out. And then inside of our app.js, we can import it in and start using it. So let's import in our search box. From components, search box component. Now, in order to replace our input, we are just going to copy over some of those properties. Now, we know that type is already on our search box component, so we don't need this. We do need the placeholder because we want to be a prop that we pass in. And then instead of handle on change, we're going to say handle change, and then we'll pass in this function. And now let's get rid of our input. And if we go back to our application, we'll see there's our search box. And we've still got our functionality. But now we've got a reusable component that we can use in multiple places. And this is what's great about React, is this component-driven style of writing code. Our search box is just a presentational component that pretty much styles an input. And then it takes any functionality that it might need in its handle change property. But now we have this reusable search box component. And this is great because we can minimize the amount of repeat code that we have. We don't have to write an input and then style it inside of a local file because we can separate it into its own component. This will become much more apparent as we start building larger and larger applications where more of the code gets reused. Right now, the benefits might not be so obvious, but it's definitely the style that we want to code in. And this is one of the huge advantages of React, is writing these smaller and smaller reusable components. Okay, now let's continue.
Hey, it's Andre here. Some of you might be wondering why we don't add state to search box. I mean, it looks like what we're doing is adding the onChange over here, giving it a function, and this function goes up a level and letting our app.js know that there was an event. But search box, shouldn't that have the search field state? Let's explore that. Now, I want you to think about this. Why wouldn't we put state here? Pause the video, think about it. Let's find out why. Remember our third point over here? A good React developer decides what changes when state changes. Let's think about this. Now, the reason we don't change the state in search box and instead we trigger whenever an event happens to handle change up here in app.js is because our other component, card list, needs to have that information, right? Remember, the way we filtered monsters was by using the search field state to filter based on the user input. So the way to think about this is like so. If we had our app over here, and this is our app.js, and in here we have the search component and the card list component. If the state was only here in the search box component, there's no way for the card list component to find out about it. Remember, because of one-way data flow, data can only flow one way. So there's no way for, let's say, the search field state to move up and down to the card list component. So instead, we want to place the state in a place where it gives us access to whatever needs it. In our case, both card list and search box need that state, that search field state, so we move it up. And the way we architect things in React is that when an event happens on a component, let's say a user clicks or types something, well, that event triggers the React event system and says, hey, something has happened. Create an event handler like handle input or handle change, and it's going to go up and let the component that has that state know that, hey, something has happened, you need to update state. and how far up that goes. Let's say we had a component underneath this. We notify the component that has the state as far up as we need to in order to pass down that information to the components that need that information. Now, if you don't get this right away, don't worry. This is something that comes with practice that we're going to explore throughout the course as we build more and more projects. But I want you to pay attention that you want to decide as a React developer what changes, what events that the users take, how far up it goes to let the state know, and you want to move the state in a high enough position so that we are still able to pass down that information to different nodes. But at the same time, if we had, let's say, a state in here that the only people that care about it is these two components, well, if that's the case, there's no point bringing up the state all the way up here. You want to place the state over here because all these components don't really care about any of this. Again, this is a topic that we'll cover a lot more, and structuring state is a very big topic in React. But I want you to start noticing these things. Let's keep going.
Welcome back, guys. In this lesson, I'm going to take a deeper dive into writing methods on classes, because right now is actually a good opportunity for us to explore a very fundamental thing in not only JavaScript, but also in React. And that's the idea of writing our own methods on our class components. Now, right now, we pass in this anonymous function into our search box's handle change in order to set our state. And we know that we've seen the this keyword a couple times now. What is it actually representing? Well, this is a special keyword in JavaScript that references the context in which it's being invoked. So what does that mean? Well, when I say this.state, we know that I'm trying to reference the state on our component, right? Our class component. The only reason that JavaScript is able to say, oh, when we're calling this.state, I want the state object on our component is because the this keyword is set to the context of our class component. Now, the weird thing is that in JavaScript, when we write our own class methods, we'll see that the this keyword actually gets bound differently depending on how we write the class method. Now, we've already seen class methods in our app component when we look at, say, the component did mount, which is a lifecycle method, as well as the render. And inside of these methods, they take this format where it's the function name, the brackets, and then the squiggly brackets, but the this keyword is bound. Now, the reason that this is actually happening, where the this context is getting bound inside of these methods, is because when we call super, we're actually extending the functionality that exists on component, which we get from React, that has these lifecycle methods and render, because we didn't write them. We're like borrowing them from component. And when we borrow them from component, component actually sets the context of this inside of them for us to our class components. If we were to write our own method, for example, to represent this method that we're passing in, we would have to be careful about how we write it. Now, let me show you. Now, the reason in the first place we even want to rewrite this method in its own class method is because there's a chance that we might want to use it more than one place. And we don't want to write code more than once. We just want to put it in one place, pass it in, and then change it in one place if we have to, and not have to change it in multiple places. Now, how we would do this is we would write this handle change method here, right? Taking the same format that we see. And it would take some event, right? Which is the synthetic event we're getting back from our input, as you remember. And then we call this .setState in it. And now we're able to actually pass handle change into our handle change property on our search box. Now we can write it like this because we're passing the whole callback through to it, right? E is being referenced in the function definition, so we
even though earlier we were explicitly writing it out like this, this is the same equivalent thing because this.handleChange is referencing this full function with the e signature. But if we were to save this, we'll actually see that our original conversation, which was about the this context, is undefined. If we start typing, we'll see that we get an error. It says that cannot read property set state of undefined. And it seems that this is undefined. Well, why is this? Well, this actually has to do with the way that functions behave in JavaScript. When we put handleChange on our app, all it knows is that if we say this.handleChange inside of the context of our app, it points to this function. But it doesn't actually set the context of this. The reason for this is because JavaScript by default doesn't set its scope of this on functions. You have to actually explicitly state what context you want this to be. For us, we want this to be our app component. And the method in which we can do it is to define it in our constructor. Because our constructor is the code that runs first, before anything gets called, right? So we want to make sure that the context of this is correct in all of our methods before any code gets written. So what we could do is we could say this.handleChange is equal to this.handleChange.bind and then this. Now, what is .bind? Well, .bind is a method on any function that returns a new function where the context of this is set to whatever we passed to it. And the context of this that we're setting in handleChange, right here, is the this keyword that is defined inside of our constructor, which knows that it's our component. And now if we save, we'll actually see that it'll work, as it was before. Now, this is actually a very verbose way of writing code, because that means that for every new class method that we write, we have to bind it. We don't want to have to do that. We can actually leverage ES6 arrow functions and a unique characteristic about them that allows them to set the context of this in whatever it was that declared it in the first place. So what do I mean? Well, arrow functions automatically allow you to set this when this thing is defined. So when our component is getting run by JavaScript for the first time, and it's like, oh, I got to instantiate this new app class, it checks inside and it sees that there's this handleChange method that points to an arrow function. So then it defines the arrow function based on what code we've given it, right? And the moment it sees the this keyword, it's like, oh, this is an arrow function. I'm going to automatically bind this to the place where this arrow function was defined in the first place. And the context of this arrow function is our app component. So that's the crazy thing about arrow functions, is that you actually cannot call .bind on them. They automatically get what's called lexical scoping, which just means that they bind the this context to the place where they were defined in the first place. And we can actually see this now, that it will continue to work as it did before, right? Even though we're not calling the bind in the constructor anymore. So this is really handy for us because it saves us that extra step. Now, in order for me to prove that this is lexical scoping, another way I can show you is inside of our browser. The highest level context is our window object. If I were to define a function called newfunc, and what we're logging is console.log this. When we invoke newfunc, we'll see that this is that window object. When JavaScript saw us define newfunc to this function and brought it into existence within our JavaScript context so we could start using it, it had to lexically scope this to the window object, because the window object was the context in which our new function, our arrow function, was given its existence. This is the same case with our handle change method. When handle change was declared, which means that when JavaScript first created our app component, it also defined all of the methods on our components, including handle change. And it saw that this was an arrow function. And because of this, when this arrow function came into existence to JavaScript, it was going to bind any references to this inside of it to the context in which it was defined, which is our app component. Just like we saw with our myfunc in the browser, that's what happened with our handle change. And this is great because if we want to write class methods, we just write them with this arrow syntax, and now the context of this is what we expect it to be, without us having to write all of that extensive binding code if we were to write it the other way. So with this in mind, it makes it easier for us to write our class components and their methods.
Hey, it's Andre here. I want to do a quick exercise with you. Based on what we've learned so far, this is going to be a little tricky. So let's see how you do. I've created here using Code Sandbox just a simple basic component. It's an app component. And here we have our constructor. And the important part is this render. We're rendering 4 buttons, as you can see here. Very beautiful page, I know. Now here we actually have 4 buttons with different ways that we're assigning the handle click function. The first button actually runs the function like this because of these brackets. The second one, handle click 1, looks like this. It's defined right here inside of the component, and it logs button 1 clicked to the console. The next one, handle click 2, is up here. It's saying this.handleClick2 equals this.handleClick1.bind. Remember, handleClick1 is here and binds to this. And then the next one, handleClick3, is a function, or because this is part of a class, it's a method that's using arrow functions. Okay, so what do you think is going to happen? Remember, this is just a simple component. All we have is these click handlers. We actually have 1, 2, and 3, and all 3 of them are being used in different way. I want you to predict what's going to happen. First, I'm going to refresh the page. Then I'm going to click on 1, then click on 2, click on 3, and then click on 4. I want you to pause the video and write down what you think is going to show up inside of the console. So I'm going to open up the console over here, and we're going to go one by one. So write down what you think is going to happen. This is a little tricky. So if you don't get it 100%, don't worry. You're not a terrible developer. We're just learning. Ready? All right, time for the answer. I'm going to refresh the page. All right. And we see right away that there's a console. So let's click over here. And it looks like button 1 was clicked. But I didn't click this button. What just happened? Well, we're invoking the function whenever we render, right? So here, when React renders this, it runs this function because, well, we call it right here. This is why we don't call a function when it's an event handler. We assign it a function so that when the event happens, it actually runs. So if I click 1 here, nope, nothing happens because there's nothing assigned to it. This is just, we pretty much just said, hey, just run the handle click function. That's it. So we don't want to do that. What about the second one? Let's click on 2 here. I get button 1 clicked. Why is that? Well, because we now assigned handle click 1, which is over here, and we ran this. Awesome. Now, if I change this to have this keyword in it, you see that this refreshed, and this initially is the app, but as soon as I click on button 2, I get undefined. And this is something that we talked about before with this keyword. Now, this undefined over here, if we wrote it like this, would actually refer to the actual button, the actual element here. All right, enough of that. Let's go back. Let's click on this one over here. Click 3. Ready? Well, let's click on 2 first and then click 3. Button 1 clicked. Why is that? Well, handle click 2. And by the way, I don't know if you can hear this, but it is raining really, really hard outside. So if you can hear that, sorry. But I swear it's just the rain. All right. So handle click 2 here is equal to this dot handle click 1, which is this function, and we bind this here. Now we run this console log. But if I change this to this now, and I click on 3, look at that. This is now the app. So this is what we're doing with binding. We're making sure that, hey, this is going to equal the app because we're going to use it later. Awesome. All right, final one. Let's go back to what we had before. What happens when I click here? When I click on 4, I get button 3 clicked. Because handle click 3, which is right over here, well, this just runs. If I now console log this and I click run, let's click 4 here. Look at that. I get the app without having to do this ugly bind up here that often confuses people. The beauty of arrow functions. All right, did you get that? If you didn't, don't worry. These are pretty much the rules. Once you memorize them, that's it. It's fairly simple. So I'll see you in the next video.